All right, so hello everyone. Once you've finished clapping, welcome to my Sounds of Scala.js talk. I'm very happy to be here in Poland. Not my first time. I still can't really speak much Polish, except for na zdrowie. So yeah, that's all I need. So yeah, as I said, my name is Paul Matthews. I'm going to talk to you about generating some musical sounds. Hopefully musical, with our favorite programming language, Scala. In particular, I'm going to be using Scala.js. So these days, I'm a London-based back-end software engineer at a company called ClearScore. I build like microservices with Scala to send data to banks and other fintechs. I haven't always been a software engineer, however. So here are some bullet points from my previous life and career in the music business. So you can see at the top there, I grew up in New Zealand. So now you know why I have a funny accent with like a singular vowel. And I don't really like this part. I don't have to say it in public. But factually, in New Zealand, I'd have to be classified as a rock star. If you're uncomfortable right now, I just call myself that. I mean, I am too a bit, but it's a very lame thing to call yourself. However, we are engineers, and engineers use data. So it's a data-driven classification. I think we can move on. What it also evaluates to is that I spent the better part of about 25 years as a professional musician and audio engineer. I played bass in bands, and I worked in recording studios as like a sound engineer, producing other bands. And that went on for about 25 years before I did like the sort of major career pivot. And I enrolled in a university degree doing computer science, and ultimately I became a software engineer and a Scala developer. So this is why I'm here today, talking about this intersection of my life in Scala and my life in music. Which brings us to the key points of today's talk. So, is Scala.js the future of web audio applications? And this is the question that I want to try and answer by the end of this talk. On the way to answering this, we're going to traverse the following topics. We're going to have a little look at the Scala.js web audio space. I've got a few little apps that I've sort of cobbled together to show you. Second, what I'm going to do is I'm going to show you how we can like wrap a JavaScript library using Scala.js. And then finally, we're going to build our own synthesizer with Scala.js using like web audio API components. Well, that's the idea anyway, so awesome. So let's just take a look at some of these applications. Yeah, and this one here was the first one that I built. And I built it to do a talk like this, Scala Days last year. And then I used the Laminar UI library, and I wrapped this JavaScript sound and music library called Tone.js. I wrapped that for the audio. Now, I actually wanted something to sort of select and play songs, but it was a case of like adding just one more button. And then I kept adding buttons, and then I added these piano keys here so I could try out the sounds and stuff that Tone.js had. Now, the next app, this one here, which I didn't really scale for a screen like this, but I mean, you get the idea. This is my like reimagined Roland 808 drum machine. Again, I'm using Tone.js, I'm wrapping Tone.js for the audio in this one. But this time around, I used Tyrian for the UI library. And I specifically set out to make a drum machine here, and then I was really wanting to try out Tyrian. And then this third one here, this is like built with vanilla Scala.js. I'm going to try and scroll here. This is weird on a very big screen. Yeah, so this here, we're just going to use this today to sort of demonstrate how we can build synthesizers and stuff. The difference between this one and the other ones is that this one's not using Tone.js. We're cutting out the middleman. We're going straight to the web audio API. Of course, we're just checking out this first app here again. And like I said, key purpose was to play some songs. Now, to play songs, you use something called a sequencer. So I'm going to try and show you this sequencer. It does what it says on the tin. It sequences the notes in the song, or schedules them perhaps. Just ensures that the right audio is played at the right time. So let's just see if we can play that. All right, try again then. I'm sure they could be louder, Doesn't sound very rock and roll. All right, so I'm going to stop that before the app crashes. That's the sequencer in action, all right? So it's all well and good. You can hear sounds playing there. We're sequencing, but where are these sounds coming from? So they're coming from two sources. They're coming from samplers, and they're coming from synthesizers. And in this case, they're both courtesy of Tone.js. Now, samplers, these load and play audio files, so like WAV files, MP3s. It does it when the sequencer tells it to. So I do have some samples. I can show you examples of samples. Here's some here. So that's actually my voice. Dum dum dum. It was the first thing I recorded. I know it's kind of funny, really. Now I do have some nice sounds though, and here's something a little bit better. A guitar my friend Harvey recorded for me. And I've got some piano as well. See if I can play some piano on my keyboard. All right. Obviously, I'm taking any opportunity to play. Yep. Thanks. So those are samples. Next we have synthesizers. We often call these synths. So there's no recorded audio files here, okay? So these generate electronic sound by combining wave oscillators, filters, amplifiers, modulators. Now Tone.js has a pretty good range of synthesizers. I would like to probably show you all of them, but 30 minutes. So I will just come up here and show you a couple. So first up, here's the plain old synth. It's like this. Yep. Then we've got this one here, an FM synth. Yep. We have an AM synth. Even it out. Okay, well, I better not keep going, but this is my favorite one. Yeah, something I think people in Poland would understand. I know Poland has a good rock following. There's this one here. This surprises me. I'm not sure what you use it for. If anybody's got a use for it, let me know. But what you can see is that we've got like a range of different sounds to suit our sort of creative requirements. And hopefully by the end of this talk, we can build something that might even sound a bit better than that. Not sure. Cool. So, we've had a quick look at some web audio apps now, and what we can produce using Scala.js and wrapping a JavaScript sound library for the audio. So for these of you who have never done this before, I'm going to run over how we can use a JavaScript library with Scala.js, just because it's not that hard, and it can be a very useful tool. Does anybody here already wrap JavaScript libraries using Scala.js? Can I get an indication? Yeah, not very many. I'm interested. How many people here consider themselves full-stack Scala developers? Dan, put your hand back up. I saw you. I know Dan is. All right, cool. Yeah, so anyway, it's a very useful tool, but we are going to chat about why we would do such a thing. Oh yeah, and of course, I did assume that everybody knows what Scala.js is all about. If you don't, it's a compiler and ecosystem. It allows us to compile our Scala source code into JavaScript and run it in a web browser, as opposed to Java bytecode running on the JVM. Why would you go JavaScript? Well, so you can build complex interactive web applications, deploy stuff on the web. Web browsers potentially being the most looked at entity on the planet these days. I asked ChatGPT, didn't give me a definitive answer, but it did support the notion that web browsers are very commonly looked at. Now the reason that I went for JavaScript for my first musical app was, at the time I was new to Scala, and so of course I couldn't find a Scala audio library. So the JavaScript library was the best option I had at the time, best and quickest option, and that was using Tone.js. So yeah, for my use case, it was perfect. And I do think that it could be the same for many use cases, because Scala.js allows us to exploit the huge amount of resources in the JavaScript ecosystem. integrates seamlessly with HTML, CSS, all that other web tech. And now maybe we can look at it as less what sort of JavaScript offers Scala, and more as what Scala offers JavaScript and web development. Because we can take all that good stuff that we love about Scala, and we can leverage that to build web apps that are actually like robust, type-safe, extendable. Yeah, and in some cases, Scala.js can like optimize the generated JavaScript code, potentially leading to better performance than handwritten JavaScript. Cool, so hopefully I can just quickly show you how straightforward it is to use a JS library in Scala.js. And this here is the basics of it. So firstly, what we have to do is we have to install the JavaScript library using npm. I do think it's kind of cute that I've dedicated a whole slide to a one-line terminal command, but you do need to do it. And we're also going to need a bundler. So we need that we need to add it to our plugins SBT file. The bundler is going to play like a key role in integrating our Scala.js output with the JavaScript ecosystem and manage the npm dependencies and whatnot. So I'm using the Scala.js bundler here. There is another few perhaps, but this one here actually under the hood is using Webpack. Cool, so then in our build SBT file, we need to enable the plugin, and then in our project settings, we need to add the tone package to our npm dependencies. And then to be fair, that should actually be it for the config. And then we can just get straight on and start using this JavaScript library in our code. So we do this by defining something called a facade type, which is sort of a typed API for JavaScript libraries, similar to a TypeScript type definition. And so this is what that looks like. And just to break the steps down, firstly, we're going to create a standard Scala object. I've aptly named it tone, which extends JS object. And then we add this JS native annotation. So what this does is it tells the compiler that the subsequent definition is a native JavaScript entity to be provided externally by JavaScript at runtime. We can also add this JS import annotation here on line 2 to import members from a JavaScript module. So what I've done is I've essentially created this parent object here for the tone library, and then all the classes and methods that I want to use from that JavaScript library, I'm just going to put them inside this object. And in the case of tone.js and audio, this is going to be samplers, sequencers, synthesizers, audio control, all inside this object. So let's take a quick look at one of these classes. Yeah, and this one here is the synth class, as you can probably see. And what it does is it's wrapping the synth class in tone.js. I did show you that before, but just in case you forgot, let's go up here. And here it is here. Yeah, so here's the synth class. Cool. And so, again, we see this JS native annotation. Now, the import name is going to be inferred from the name that we've given the class. So we've called this synth. It's going to look to import the same name from tone.js. And now the key method of interest within this synth class is this trigger attack release method. It's a funny looking name. You'd be forgiven for thinking that it performs an act of aggression, but it's actually very wholesome and very useful. And it basically it starts a note, it determines how long you hold the note, and when you stop the note sort of thing. So you can see here it takes 4 arguments. Firstly, note, A, B, C. Secondly, we've got the duration, how long. Time is going to be when we're going to play it. So this is what the sequence is going to use to determine when this note plays. And then finally, velocity is kind of how loud you play the note. So I'm just going to show you the JavaScript counterpart as well in the JS library. And when I say JavaScript, you can see it's actually TypeScript. So this is a small section of the class, but it's really just to show you how you can directly utilize this trigger attack release method from the synth class there. So that's pretty much it. I think that covers how we go about using a JavaScript library in our Scala.js project. So let's move on now and just have a look at that in use with this 808 drum machine. Cool. So I came in here a little bit earlier, and I had real trouble using this mouse on this huge screen, but I did program in a beat, so I'm actually just going to start this beat. Yeah, so that beat, that should sound familiar to you, and those sounds should sound familiar to you because this 808 is like a classic, beloved drum machine. So, the reason that I've modeled one. And so when it first came out, 1983, it actually wasn't very popular because it didn't sound like real drums. But then a few years down the track, once sort of, broke musicians could buy them cheap in second-hand stores, where it actually blew up. And obviously, I'm kind of hoping the same thing happens for my music career, but I mean, we're not talking about me right now. But yeah, you can see if I take you up here, I can show you the original. That's the original from 1983. Very handsome bit of kit. Ahead of its time, dark mode. You can see the single strip of buttons down there. Obviously, they were restricted by the cost of components. I'm not. I've got 4 strips there. Now, the reason I've used 4 strips and not stayed faithful to the original is that we can see the drum pattern there, right? So if you program drums or you're a drummer, you can probably see what that beat there is. So yeah, I feel I should do some more with it, seeing as I'm here, but you guys have not experienced trying to use a mouse behind your back on a massive screen like this. Are there any metal drummers in the house? Are there any fans of metal in the house? There they go. Okay, this beat's for you then. Obviously, you like it nice and fast. And there we go. Oh, all right, cool. So that's the drum machine. Yeah, indeed. Where are the noises coming from? I mentioned samplers before. I mentioned synthesizers. In the case of that 808, they're actually samples. I used recordings of the original synthesis, so it's a bit like, art imitates life. They were trying to create digital versions of real drums. Now, 40 years later, I'm using recordings of their attempts to make real drums. But yeah, so for this, we are indeed using a sampler. Here's the definition of that, the Scala.js definition. Same thing as the synth. We're going to use the same method. So what we do is when we're instantiating this, we pass it like a JavaScript object of samples and the location of the files. And then to play those samples, trigger, attack, release. So same thing we saw before. Note, how long, when, how loud. Yeah, and here's a look at the sampler in action. Taking that JSON object of samples. In this case, it's a single sample. And that note A1, that's the note that you use to trigger the kick pull WAV file, which is me making a kick drum with my mouth, kind of like dub dub, which actually sounds like this. Here we go. I've got to show you. Where is it? Here it is up here. But I've pitched it down. Yeah, see, I pitched it down with the sampler. So these are the cool things that we can do. So once the file is loaded, we can call that trigger, attack, release method and pass it the note. And so pretty much from there, Tone.js has us covered. We're going to get some sound sort of out of our computer speaker. Awesome. So 808's coming along. I'm fairly happy with it. Now the audio, as I've said, we're still wrapping Tone.js and happy with what that can do for that particular use case. However, what I would like to do is get more low level. Instead of wrapping Tone.js and using Tone.js synthesizers, is look to build one ourselves by programming direct to the web audio API and effectively to start sort of creating this Scala-specific music library. So as a start, let's have a look at how we can create a very simple synth with Scala.js. It's actually not as difficult as it might sound, but we should confirm that we're all on the same page with what a synthesizer is. Yeah, so here's where it all started. It's Robert Moog with his original Moog modular analog synthesizer. And so with these contraptions, you'd use these cables to plug in all these different components to build your synthesizer and create and modify sounds. In this black and white photo, it's a bit hard to see the cables, but you can see them a lot better here. And when I look at that photo, I think one thing: side effects. But what exact components are we plugging in and connecting up here? All right, firstly, we need one or more oscillators, a device for generating pure sound waves. So for example, like sine waves, sawtooth waves, some fundamental audio signals that we can combine and create some more complex sound with. We need some filters, so they can shape the sound by removing certain frequencies. So some common types of filters include low-pass filters, high-pass, band-pass filters. Envelopes. So we've actually seen a kind of envelope already with that trigger attack release method. Basically, envelopes control how the sound evolves over time. So you normally have like attack, decay, sustain, and release. Amplifiers control the overall volume of the sound. So this amplifier here, I was just looking for a nice picture. It's more of a novelty component. The amplifiers that we're more likely to see are this. But yeah, it wasn't very exciting, so I found something that looked a bit more colorful. But yeah, I've shown you these like sort of charming, inspiring photos of great gear. But I don't want to mislead you. It's surprisingly easy to make awful and horrible sounds with them. I'm just prepping you for what's to come, because I didn't actually say that Synthesizer was going to sound nice or anything. So let's have a look at the Web Audio API's version of these components that we can use for building our first soft synth. Yeah, cool. So firstly, we've got the Scala.js facade type definition for an oscillator node. So take note that the oscillator node is extending an audio node, and this is because the Web Audio API, it arranges components as a graph of nodes. Next, we have a gain node. So ultimately, we can set the volume, like the amplifier. Here we have this biquad filter node, which we use to filter out some frequencies and shape the sound a little bit. So what I want to do here is I want to make the simplest possible API to instantiate some of these nodes. And so as a start, I've defined this oscillator ADT to try and make it a really quick, self-explanatory API for creating oscillators. So there are 4 basic wave types we're starting with: sine oscillator, square wave, sawtooth oscillator, triangle. And basically, I just want to be able to instantiate the oscillator I want and then call play on it. So I want to get going. So what I've also done is I've built in a gain node and a filter node into the ADT. Yeah, so just looking a little bit more at that implementation. On line 2, we're creating an oscillator from the audio context. Now, the audio context is the sort of foundation for playing audio in web applications by creating and managing an audio processing graph. Now remember, we talked about needing an amplifier because we need to control the volume. So on line 9, we create an amplifier for doing that. And ultimately, I've just wrapped the gain node in that. And then finally, on line 10, we've got a low-pass filter. Again, I mentioned filters, shaping the sound. Cool, so now we'll take a look at the play method, and we can start generating some sound with that. Now, do you remember that? You remember the photo of Robert Moog and his vintage synthesizer with all the cables? That's what I want to do here inside the play method. I want to plug in these components. So on line 5, we're going to plug the oscillator node into the low-pass filter. And then in turn, on line 6, we're going to plug that low-pass filter into the amplifier. And then finally, on line 7, we're going to plug the amplifier into the audio context destination, which is ultimately going to offload it to the browser's sound output. All right, cool. So now we should have a listen to some of these oscillators and see what they're all about. Should be over here somewhere. Oh, there we go. Cool. So here's the first one. It's a sine wave. Yep, I'm sure you've heard that before. Sawtooth. I mean, you're kind of lucky there's only 4. All right, awesome. So those are our 4 different fundamental sound waves. Could you put up your hands if you think any of those sound musical? Someone up there. Someone with vision. All right. So now what we're going to do is we're going to have a look at like mixing some of these together. So let's get that back to that. There we go. Yeah, so what I'm doing here is I'm instantiating all 4 of the types. I don't need to do that, but it's something interesting. Starting frequency 440 hertz, which is like concert A. Now you can see that I'm changing the frequency though in the square wave, the saw wave, the triangle wave. I'm trying to make it a bit more interesting here. So firstly, I've dropped it an octave in the square wave, divided it in 2. Then in the saw wave, I've dropped it another octave, so I've halved it again. So now we're going to have like 3 stacked octaves. So it's going to sound a little bit better than just running all of them at the same time. Now the triangle, this one's probably the most cool, I think. We're only reducing it by 3 hertz. So we're coming in at like 437. It's slightly detuned. What is it going to do? Like the human ear, there's actually quite a bit of play you have before you think something's actually out of tune. So this is going to hopefully make it like a little bit thicker, make it sound a little bit thicker. Anyway, let's see if that's true. So we'll roll back to that. And then come down here. Okay, I never imagined having to scroll so much on a screen like that. Okay, so there's a sine wave. Off it goes. You can see here. Obviously, I'm just controlling the gain with the slider there. I'll mix in some sawtooth. Okay, here we go. That's probably better. Can you hear that? All right. So that is because it's detuned that we're getting that sort of pulsing feeling, right? So I'm going to run it again, but some sort of square wave. All right. Oh, I want to stop there. It is a little bit like someone leaving their hand on the car horn, but I think we can make use of it. I mean, does anybody think that sounds nice? No. Well, more than the sine wave anyway. Thank you. Dan, I saw you put your hand up when I looked at you. All right. Well, you know what, all you people, you do have vision. Because it's all about context, right? Oops. Oh. All right. Yeah, here we go. Thank you very much. Thank you. I'm tempted to ask you to put your hands up if you think it sounds good now, but maybe just sit there. So that is actually pretty much all I have to show you. I'm almost out of time. No, I think I can sneak a little bit more in, actually. That's true. Let's just go for it. So we've also got some of these other controls here. I mentioned to you the filter. So we run that again. Let's just get this going. Here we go. Here's the low-pass filter. It's letting through lows. It's basically going to cut the highs off. There you go. I suppose I should stop doing that. You can also do like a, you can use the pitch here. All right, that is the end of my talk. Cool. Before I leave, I did mention the Scala 3 specific music library. So here's this repo where this project is underway at the moment. And I've called it Sounds of Scala. I've already been like hassling some of you to get involved. We have some submissions going on at the moment for a pair of like Google Summer of Code projects, which I'm co-mentoring alongside Noel Welsh through the Scala Center. So looking to make some progress on this over the next few months and get something usable and fun together. So if you're a musical kind of Scala developer and you put your hand up at least once and you want to contribute with a small task, then let me know, because there's a whole lot of like small tasks that are fun that you could probably do in like half an hour or an hour. Just long enough to sort of get you sucked in. I also want to say, if you like the talk today, feel free to check this one out on YouTube. It's my Sounds of Structure talk from Scala days, which focuses a little less on the audio and more on modeling music with algebraic data types. It's a bit more sort of theoretical music-based. And yeah, cool, so that's all we've got time for. Thank you very much for coming along and not leaving when I started playing sine waves. What we talked about, I showed you some Scala.js music apps. Then we looked at wrapping a JavaScript library with Scala.js, not specifically just an audio one, but you could do it with anything. So potentially very useful. Then we built ourselves a very simple synthesizer using Scala.js. And finally, I tried to recruit some of you to work on the library. Is Scala.js the future of web audio applications? Obviously, all right. Here's a QR code while I potentially stand up here for negative 12 seconds and take some questions.
So clap your hands first.